Experiencing slower information processing, such as taking longer to understand instructions, needing extra time to respond in conversations, or feeling mentally sluggish, can seem like a minor inconvenience at first, but it is often an early warning sign that the brain's neural networks are under strain. This slowing reflects diminished efficiency in the communication pathways between neurons, particularly in regions like the prefrontal cortex, hippocampus, and the parietal lobes, which integrate sensory input, memory, and decision-making. While occasional delays in thought can occur from fatigue or distraction, persistent or increasing sluggishness signals that cognitive circuits are losing their speed and flexibility. Left unchecked, this subtle change can escalate into more serious deficits, affecting memory, attention, and overall executive function. The dangers of ignoring slower cognitive processing are significant. As neural efficiency declines, even simple tasks, reading, responding to emails, following a conversation, or making decisions, require disproportionately greater effort. Mental fatigue sets in more quickly, concentration wanes, and mistakes become more frequent. Over time, this decline can erode confidence, increase anxiety, and reduce overall productivity. In social or professional contexts, slower processing can create frustration or embarrassment, leading to withdrawal or reduced engagement, which further deprives the brain of stimulation necessary for maintaining neural plasticity. The cumulative impact is not merely functional, it signals that underlying neurobiological mechanisms are being compromised. Biologically, slower processing is often tied to oxidative stress, chronic inflammation, and vascular or metabolic dysfunction. Neurons require a steady supply of energy and optimal communication across synapses to function efficiently. Oxidative damage to cell membranes and mitochondria impairs these processes, while neuroinflammation disrupts neurotransmitter signaling and synaptic plasticity. Reduced cerebral blood flow, often a consequence of hypertension, obesity, or sedentary lifestyle, limits the delivery of oxygen and glucose to critical brain regions. Additionally, insulin resistance or poor glucose regulation can deprive neurons of the energy needed for rapid signal transmission. Together, these factors slow the brain's capacity to integrate information, creating the sensation of mental fog or delayed thinking. The warning signs are often subtle but progressively worsen. You may notice it takes longer to recall names, process multi-step instructions, or make decisions that were once effortless. Everyday conversations may feel overwhelming, particularly in situations that require multitasking or rapid response. Mental sluggishness may extend to problem-solving tasks, learning new skills, or following complex written or verbal instructions. Unlike acute cognitive lapses, slower processing develops gradually, often unnoticed until the gap between your performance and your expectations becomes frustratingly clear. Lifestyle factors can accelerate this decline. Sedentary behavior limits neurotrophic support and cerebral perfusion. Diets low in antioxidants and polyphenol fail to protect neurons from oxidative stress and inflammation. Chronic stress elevates cortisol, impairing synaptic efficiency in the hippocampus and prefrontal cortex. Sleep disruption prevents memory consolidation and neural restoration, further contributing to slower thought. Over time, these lifestyle and environmental pressures combine to create a brain that is not only slower but more prone to error, fatigue, and cognitive fatigue, a pattern that can steadily undermine independence and quality of life. Nutrition is a cornerstone of prevention. Polyphenol-rich foods such as blueberries, dark chocolate, green tea, and other colorful fruits and vegetables support synaptic communication, reduce oxidative stress, and enhance neuroplasticity. Omega-3 fatty acids from fatty fish, flax seeds, and walnuts maintain neuronal membrane fluidity, promoting faster signal transmission across synapses. B vitamins, choline, and magnesium support neurotransmitter synthesis and energy metabolism within neurons, allowing the brain to process information more efficiently. Maintaining adequate hydration is equally important, as even mild dehydration can impair cognitive speed, attention, and working memory. Cognitive stimulation is another key intervention. Engaging in challenging mental tasks, puzzles, strategy games, memory exercises, learning new skills, or practicing rapid decision-making strengthens synaptic pathways and enhances the brain's ability to process information quickly. Incorporating tasks that require multi-step reasoning, pattern recognition, or timed responses can train the brain to maintain efficiency and adaptability. Social interaction also plays a critical role, as conversation and collaborative problem solving stimulate attention, working memory, and processing speed simultaneously. Physical activity complements these strategies. Aerobic exercise improves blood flow to the brain, enhances oxygen and glucose delivery, and stimulates the release of brain-derived neurotrophic factor, BDNF, which strengthens synapses and supports neural plasticity. Even moderate, regular activity, such as brisk walking, cycling, or swimming, enhances cognitive speed, attention, and mental flexibility. Resistance training also contributes by improving systemic metabolic health, reducing inflammation, and supporting the energetic needs of neurons. Sleep hygiene and stress management are essential. Deep, restorative sleep consolidates memories, clears metabolic waste, and allows neurons to recover, while chronic stress elevates cortisol, impairing synaptic efficiency and reducing processing speed. Mindfulness practices, meditation, yoga, and structured relaxation techniques can mitigate stress and support prefrontal and hippocampal function. Without these interventions, slower information processing can escalate, increasing the risk of memory impairment, attention deficits, and broader executive dysfunction. Ignoring persistent slow cognitive processing can have long-term consequences. Mental fatigue, reduced efficiency, and increased errors may lead to frustration, social withdrawal, and decreased engagement in cognitively demanding activities. Over months and years, the cumulative impact of oxidative stress, neuroinflammation, metabolic compromise, and lifestyle neglect can accelerate age-related cognitive decline and increase vulnerability to neurodegenerative diseases. Early recognition and proactive management through nutrition, cognitive and physical activity, hydration, stress reduction, and sleep optimization can preserve neural efficiency, protect memory circuits, and maintain mental agility. Slower information processing is not an inevitable part of aging. It is a signal from the brain that underlying neuronal pathways are under stress and require support. By responding decisively to this warning sign, individuals can strengthen neural communication, maintain cognitive speed, and safeguard both functional independence and quality of life. Consistent intervention today can prevent minor sluggishness from evolving into significant cognitive decline, ensuring that the brain remains agile, resilient, and responsive well into later years.